Hey guys, welcome to Algo Forces. Today we'll be moving ahead with Leetcode problem 1261, that is find elements in a contaminated binary tree. So let me read through the problem first. So it says given a binary tree with the following rules, that is root dot value equals to 0 for any tree node. If tree node dot val has a value x, then tree node dot left and tree node dot left is not equal to null, then tree node dot left dot value equals to 2 into x plus 1. And similarly, if tree node dot val has a value x and tree node dot right not equals to null, then tree node dot right dot value equals to 2 raised to x plus 2. So they are giving us a binary tree and saying that the value of the elements is fixed, that is root dot value equals to 0, left is 2 into x plus 1 and right equals to 2 into x plus 2. And now they are saying that binary tree is contaminated. So basically they'll be changing all the elements of the binary tree, and each of the values will be changed to -1. So they are saying us to implement the find element class, where find elements initializes the object with the contaminated binary tree and recovers it, and find method returns true if the target value exists in the recovered binary tree. Okay, so I'll move to the approach now. So in this kind of problems where we are given to complete two methods, that is initial one which initializes and one which finds. So basically find method will be called again and again, right? So we will try to complete it in mostly order of one, I mean constant time complexity, or maybe log n, that is as much less time complexity as possible. Okay, so whatever logic we have to make, it should be in initialize method, because it gets called only once. Okay, so now let's try to see the approach. This we will be writing in the initialize, that is find element method. So now we are given this tree and we have to find this all elements if they exist in the tree. So we do not care whether it is -1 or anything. We have to anyways construct the tree again. Okay, so now see there are five nodes. Okay, so because there are five -1, so anyways we do not, we are given in find elements, we are given root, right? So we do not have to even see this array. So let's say I am given root, I will directly make it 0. Now I will check if root dot left is present, that is not equal to null. So I will directly make it 2 raised to 0 plus 1, that is 1. Similarly, if root dot right exists, so I will make it 2 raised to 0 plus 2. If again I'm at 1, if 1, if root again, this is the node, so if node dot left exists, so I'll make it 2 raised to 1 plus 1, that is 3. Again this would be 2 into 1 plus 2, so this will be 4. Okay, and now my element is 2, but its left and right does not exist, right? I mean they must be null while you are traversing. So I'm doing nothing, and so basically I want to complete the find method in order of one time, or maybe as least time complexity as possible. So obviously we are going to use hash set. So as and when we are traversing the nodes, I'll be adding it in the hash set, and in find method I will check whether that hash set contains the particular element or not. Okay, so in our case, let's say I want to find one, so I have all these elements in my hash set. So I will check if one exists in the hash set. Yes, it does, right? So I will return true. Now coming to 3, does it exist? Yes, I will return true again. 5, does it exist? No, right? Because in tree there is no element with 5 value. So in hash set also it won't be there. So I will return false here. Okay, so what is the time complexity of this solution? Order of 1. Okay, this order of 1 will be for find method, because we are directly just checking hash set, and it would be order of n for find elements method, because we are traversing the whole tree, right? So all nodes are visited once, and the space complexity would be order of n, because we are using hash set for storing the elements. So I hope this approach is clear to you. Now let's move to the coding part. Okay, so what all do we need here? So I have find elements where I need to traverse the tree, and I need a hash set of integer, and I'll just initialize it. So I will complete the find method first. So I just have to I just have to check whether the set contains the particular target element or not. If it contains, then I will return true, otherwise false. Okay. And now coming to find elements class. So here we just need to traverse a tree, whether you can use DFS or BFS, it's up to you. Okay. So I'm using a stack. Okay. And I will by default I will just add root element, and I have to also change the value of root. So I will initialize it by 0, because otherwise if you'll directly see its value, it will be -1 as it is contaminated. Now I'll start my DFS traversal. Stack dot is empty. Till stack is not empty, I will pop the element, sorry, variable, or you can also use gnode equals to stack dot pop. Okay. Now I will check, I will have to add it in the set. Okay, and I will check if element dot left not equal to null. Okay, so in this case we will have to manipulate the left value equals to 2 into element dot value plus 1, and I will push it to stack element dot left, and similar thing we will do for element dot right. Here this is fine, and I have to make it 2, and here it should be right. Let's check the code first. Yeah, this should be tree node, and this is, and here it should be element dot right, and this is it. So now let's try to run the solution. Okay, it worked. Now I'll try to submit it. Okay, so this is it. And if you have any doubts, do comment in the comment section. And I hope you like and subscribe this video. Okay, then bye bye.